Hi everyone. Today we're going to be talking about the global atmospheric circulation. We're specifically going to talk about the direction of the wind, the Coriolis effect, why and where air rises and why and where it descends, and the general circulation impacts that it has on the different climates. So first we'll talk about air movement. So as you can see, you have high and low pressure, and air moves from high pressure to low pressure. It does not cross the isobars at 90 degrees. The Coriolis effect plays a part on this, and we'll talk about that in a later slide. The pressure gradient force causes air to start moving across the isobars, and the Coriolis effect acts as the right angles to the motion, which causes a deflection. After a little bit, it ends up balancing out and becoming a parallel motion to the isobars. This typically happens with upper air winds or geostrophic winds. So when you have more friction, which will be closer to the surface of the Earth, this lowers wind speeds and lessens the Coriolis effect. This causes the pressure gradient to take over, and because of that, the angle across the isobars toward the low pressure, it becomes toward the low pressure. So you head that way. You can kind of see that with the northeast and southeast trade winds. So another thing that plays a part with wind direction is roughness of terrain. So upper airflow is typically more parallel, while surface winds move more slowly and at a cross angle because they have to go across more terrain than upper air. So the Coriolis effect, what exactly is it? It's caused by Earth's rotation. Without it, wind would hit the isobars at 90 degrees. So in the northern hemisphere, we have deflection to the right. So the air moves to the right, as we see on this slide. And then in the southern hemisphere, it's deflected more towards the left. This is directed at airflow at a right angle, as we discussed in the last slide. So it hits that airflow at a right angle, causing it to deflect and curve. This affects air and wind direction, but not wind speed. However, wind speed does affect the Coriolis effect. So, again, the Coriolis effect doesn't directly affect wind speed, but wind speed does affect it. We also have it strongest at the poles and weakest near the equator. So this image here shows what it would be like if the Earth did not rotate and there was no Coriolis effect. And B, the bottom part, shows what it's like with it, how it rotates and causes a curve. Next, we're going to talk about why and where air rises and descends. So on this image, you see you have descending air at the top near the poles and at the bottom near the poles. And then you come in a little bit and you get rising air. And then you get in the middle descending air. So the equatorial low, this region in the middle on the equator, is ascending moist hot air, and it has lots of rain. Winds converge here, and it causes low pressure, and it's also called the intertropical convergence zone. So a Hadley cell is formed here. As the upper level flow reaches 20 to 30 degrees latitude, which is the lines on either side of the equator, it sinks back towards the surface, so we get descending air, and it creates hot, arid conditions. The subtropical high is another name for it. This area encircles the globe, and it covers all of it around the 30-degree latitude mark. This is where you have your great deserts in Africa and Australia and other places because of the hot, arid air. And then you go up to the polar easterlies in the subpolar low area. So that's your poles and polar cell part. This produces a polar front, and the cold starts subsiding and spreading back towards the equator. And here you have Ferrel cells causing the air to rise and descend. Lastly, we're going to talk about the effect it has on the climate. So you'll see with 90 degrees latitude, so that's our poles, we have the polar high, which is very little precipitation in every season. It has really cold air that sinks to the surface, and it's dry, and there's no plants that can grow. Below that, we have the 60-degree latitude. This is our subpolar low. There is lots of precipitation in every season. It has warm air from the lower latitudes that meets the frigid air from the poles, and this produces the precipitation. Here you can have forests, so we get some things that grow some vegetation. We go down to 30 degrees latitude, and this gives us wet winters and dry summers at the top. Then the subtropical high, which is dry in all seasons. And then below that, we have the summer that is wet and winter is dry. So it flip-flops again. So you get warm air here, dry air that sinks to the surface. The dry air produces little rain, and deserts are in this area, which we talked about already, how deserts are in this area. So then you get to the equator, and the equator is 0 degrees latitude. It has warm, humid air that rises, and it cools and produces a lot of rain. This is where you get your rainforests, and they have abundant precipitation all year round. So you see on here we have a diagram that shows you each area with the different climates and why it affects it because of the air and the polar fronts. And that is all for this lesson.